All right, let's dive in. Introduction to Embedded C. So, what exactly is Embedded C? Well, Embedded C is a programming language that combines the features of the C programming language with additional tools and techniques to program embedded systems. Now, you might be wondering, what is an embedded system? An embedded system is a microprocessor or microcontroller-based system designed to perform a specific task. Unlike general-purpose computers, embedded systems are dedicated to one function or a set of related functions. Let's look at some examples. These include washing machines, microwave ovens, digital cameras, smartwatches, and automotive systems like ABS. Why use C for embedded systems? The C language is widely used for embedded programming due to these reasons. Efficiency. C provides low-level access to memory and hardware, making it suitable for resource-constrained systems. Portability. Code written in C can often be compiled for different hardware platforms with minimal changes. Speed. C generates fast and compact code. Hardware control. Embedded C allows direct access to I/O registers and memory addresses. What is Embedded C? Embedded C is a set of language extensions for the C programming language defined by the C Standards Committee to help write programs for microcontrollers and embedded systems. Key features include access to input-output ports and memory-mapped hardware, the use of timers, counters, and interrupts, and bit-level operations for efficient control. Basic structure of an embedded C program. Hash include is the header file for a specific microcontroller, for example, the 8051. Then we have void main. Inside the main function, we have while 1, P1 equals 0xFF. This sets all pins of port 1 to high. Hash includes definitions for microcontroller registers. The main function is the entry point of the program. The while 1 statement creates an infinite loop to keep the program running. Finally, P1 equals 0xFF writes data to port 1, in this case turning all LEDs on if connected. Applications of embedded C: consumer electronics like TVs and remote controls, automotive applications such as airbags and cruise control, medical devices including heart rate monitors, industrial machines like PLC controllers. Let me know if you'd like a more in-depth explanation on specific topics like interrupts, timers, GPIO, or real-time operating systems, RTOs, in embedded systems. Deep dive into embedded C. Difference between C and embedded C. Feature: C language, embedded C usage, general purpose programming, programming embedded systems. Libraries, standard libraries, STDO, etc. Hardware specific libraries, reg51.h, etc. Hardware access, limited direct access to memory and I/O registers. I/O operations handled through OS or console directly through registers. Portability, highly portable, less portable, hardware dependent. Embedded system architecture overview. An embedded system generally includes a microcontroller or microprocessor, for example, 8051, AVR, or ARM Cortex-M. Memory, where ROM stores code and RAM holds temporary data. Peripherals such as timers, UART, ADC, and PWM. I/O ports to interface with LEDs, sensors, and switches. And of course, a power supply. Common components in embedded C programming. GPIO, which stands for General Purpose Input-Output. These control or read the pins of the microcontroller. For instance, P1 equals 0x0F sets the lower 4 bits of port 1. Then we have timers and counters, which measure time or count external events. Interrupts are also crucial, as they allow the system to respond to events, like a button press, immediately. An example would be where ISR stands for Interrupt Service Routine Code. Serial communication, UART. This is used for data exchange with other devices. Then there's the analog to digital converter, or ADC, which reads analog signals from sensors. Development tools for embedded C. Let's break it down by categories. First, we have IDEs like Keel UVision. Then we have MPLAB-X and Atmel Studio. Then there are compilers such as SDCC, IAR, GCC, and ARM-GCC. For programmers and debuggers, we have tools like USBASP, ST-Link, and J-Link. Simulators and emulators include Proteus and Multisim. And finally, on the hardware side, there are platforms like Arduino, STM32, PIC, and the classic 8051. Now, let's look at some example programs. First up, we have a simple Blink LED program for an 8051 microcontroller. It starts with including the library. Then, we have a delay function, where an integer I is used in a for loop, running up to 50,000 iterations. In the main function, we enter an infinite loop. First, the P1 port is set to 0xFF, turning the LED on. After a delay, P1 is set to 0x00, turning the LED off. And then, another delay. Next, we have a button-controlled LED program for the 8051. It begins with including the library. Then, we assign pin P1. 0 to the LED using S-bit LED =sign P1 circumflex 0, and pin P2. 0 to the button using S-bit button =sign P2 circumflex 0. In the main function, we enter an infinite loop. If the button is pressed, which means button equals 0, the LED is turned on by setting LED to 1. Otherwise, the LED is turned off by setting LED to 0. Alright, let's dive into some key concepts in embedded C. First up, we have bit manipulation. This is essential for controlling individual bits of registers or ports. For example, to set the first bit of port 1 high, you would write P1 or =0x01. And to clear that same bit, you would write P1 and =0x01. Memory mapping. Registers are mapped to specific memory addresses. ISR, interrupt service routine, code that runs when a specific interrupt occurs. Polling versus interrupts. Polling continuously check the status, interrupts microcontroller reacts automatically. Real-time considerations. Real-time operating system, RTOS, optional layer for complex systems requiring task management. Examples: FreeRTOS, RTX, Watchdog timer, prevent system hang by resetting the MCU if code fails to execute properly. Testing and debugging, breakpoints and step execution in IDE, LED, sensor outputs for basic debugging, serial terminal logs, logic analyzers or oscilloscopes.